let us try to understand something regarding the Ohm's law. What is Ohm's law? The statement of Ohm's law. The electric current in a metal wire is directly proportional to its potential difference. So now you understood the basic elements, the metal wire. In the circuit, we are using some connecting wires, okay, generally made up of metals because metal is a good conductor. Okay, so some amount of current is passing through this closed loop through the connectors, the connecting wires and all. So the amount of current passing through this metallic wires is directly proportional to the potential difference across its ends. That is, current across the metal wire. So I have already told you that some closed circuit we have considered. Okay, battery is connected, I current is being passing on. Okay, so this current, and here is the potential difference we are applying. The current across the metallic wire is directly proportional to the potential difference across the two ends of the metal wire. So this is the complete metal wire. Okay, this is one end of the metal wire. Okay, and here it is another end of the metal wire. So the electric current inside a metal wire is directly proportional to the potential difference across its ends, provided the temperature is constant. So what is the condition, children? Temperature must be constant. In that case, the current passing through the circuit is directly proportional to the potential difference set by Ohm's law. If you extend this, we have I can be written as, if proportionality symbol is removed, we need to replace it with some constant. That constant, we represent it with some letter 1 by R. 1 by R is some constant into V. So, proportionality, if it becomes equalness, we have to replace it with some constant, and that constant is taken as 1 by R. Okay. So, if you simplify this, V can be written as, bring this R the other side, IR, or in general pattern it can be written as V equals to IR. This is your Ohm's law. So the statement of Ohm's law is as said. The electric current through a metal wire is directly proportional to the potential difference, provided the temperature remains constant throughout the circuit. So from this, we have generated the formula as V is equals to IR, where V is the potential difference across the two ends of the conductor, I is the amount of current passing through the circuit, and R indicates the resistor. It can also be called as a resistance. Children, what is resistor or resistance? It is a device. Resistor or resistance is a device which opposes the flow of charges. Which opposes the flow of charges through the circuit such that can function properly. Okay. So, from this we can also write down the value of resistance. So, what is that? If you look into this, if V is equals to IR, then R can be written as V by I. R can be written as V by I, where R is the resistor. Okay, it offers some resistance across the circuit, and it is a device. The symbolic notation for resistor is something like this. Okay. Well, so from this, suppose if V is constant, then we can say that R is inversely proportional to the I. Okay, or I is inversely proportional to 1 by I is inversely proportional to R. That means as resistance increases, the amount of current decreases. Or as the amount of current increases, the resistance across the conductor decreases. Okay. So larger the current, lesser will be the resistance of flow of current. Okay. Well, you can also plot a graph. Let us also define something like this, children. From the formula R is equals to VI, let us look into the units. We know that potential difference is measured in volts. Potential difference is measured in volts and current is measured in amperes. So, the units of resistance is, let me write it as SI units of resistance or resistance is for R is measured in volt per ampere. It is measured in volt per ampere. And this volt per ampere is also called as your ohm. So, ohm is the SI unit of resistance. It is indicated with the symbol like this. This is the symbolic notation for ohm. So, where 1 ohm can be written as 1 volt upon 1 ampere. So, from this we can define that when 1 volt potential difference is applied across the ends of a conductor, in which 1 ampere of current is been passing on, then we can say that 1 ohm of resistance is applied across the circuit. Is that clear, children? So, where 1 ohm is equals to 1 volt upon 1 ampere, the symbolic notation for ohm is as said, and ohm is the SI unit of resistance. Okay. If you plot a graph between taking current on y-axis and voltage on x-axis, then it will be something like this. So, when voltage is taken across x-axis and current is taken on y-axis, then the shape of the graph will be something like this. Because I and V both are directly proportional to each other, as the current increases, the potential difference across the circuit also increases accordingly. Well, now let us try to understand in detail regarding the resistance. Okay. The factors on which resistance depends on. Resistance generally depends on 3 factors, children. One is the length of the conductor. Resistance depends upon the length of the conductor. It also depends upon the area of cross section of the conductor or metallic wire. Area of cross section. And nature of the material we use. So, resistance depends on 3 factors: length of the conductor, area of cross section of the conductor, and nature of the material you will be using. So, from this I can conclude that resistance depends on length of the conductor. So, larger the length of the metallic wire, larger will be the resistance offered. That means resistance and length of the wire will be directly proportional. Similarly, larger the area of cross section, lesser will be the resistance applied. So, resistance is inversely proportional to the area of cross section of the conductor. Combining these two, combining equation 1 and 2, what we get, children? R proportional to L upon A. If this proportionality symbol is removed, we need to replace it with equal to. Then some constant L by A proportionality is removed to equals to, means some constant you should replace, and that constant is represented as rho, where rho is called as resistivity. What is that, children? Resistivity. Let us try to understand regarding the resistivity to some extent. So, from this we can conclude that rho is equals to R A by L. If you bring it the other side, it will become reciprocal. So, rho will be equals to RA by L, where R is the resistance, A is the area of cross section of the given conductor, and L is the length of the conductor. Rho indicates the resistivity. Resistivity. Okay. Units of rho. What is the SI unit of rho, children? We know that the unit of resistance in SI system is measured in ohm, area meter square, and length in meter. So, further simplification gives, we have ohm meter. So, the SI unit of resistivity is ohm meter. Is that clear? And the reciprocal of resistance is also called as your conductance. Okay, children? Well, if R ohm is the unit for resistance, then the reciprocal of resistance, that means 1 by R. This is R. Reciprocal of resistance is taken as 1 by R. This is called as a conductance. Resistance, reciprocal of resistance is conductance. Okay. So, reciprocal, the unit will also be 1 by ohm. What is the unit of 1 by R? It will be 1 by ohm. So, this can be written as ohm inverse, 1 by ohm or ohm inverse. Instead of that, you can simply call it as mho. Both we can say, either ohm inverse or mho. The reciprocal of resistance is called as your conductance. Units is mho or ohm inverse. Similarly, we have the reciprocal of resistivity called as your conductivity. Okay? Well, that's it, children. Now, let us try to understand the next topic regarding how these resistors are connected. The few resistors can be connected in series and few other are connected in parallel. So let us try to understand the combination of these resistors in the electric circuits. Series and parallel combination. As we know, the symbolic notation for resistor is something like this. This is one resistor. Suppose if you would like to join two different resistors, then that is first resistor and this is second resistor. The ends of the two wires should be joined like this. The three resistors can be joined something like this. If this type of combination is called as a series combination. Remember, in the series combination, the same amount of current flows through all the resistors. Same amount of current passes throughout all the resistance that are joined in the series combination. The same thing, if you would like to understand something regarding the parallel combination. In the parallel combination, the resistors are all arranged one after the other and all the three are joined in such a way that something like this. Same potential difference is maintained across the two ends. Same potential difference across the two ends indicates your parallel combination and same current across their ends indicates your series combination. Here the amount of current will be divided into the resistors according I1, I2, I3. But in the series combination, though the potential difference is different, potential difference may be different, but current remains constant. So if suppose some I current is passing, the same amount of I current is passing across all the resistors in the series combination. Well, so as I said that The potential will be different here, maybe some V1, V2 and V3. Then what is the total potential difference applied across all the resistors is given by V equals to V1 plus V2 plus V3. The total potential difference across all the resistors, series resistors is V is equals to V1 plus V2 plus V3. But we know that V is equals to IR. V can be written as IR. Okay. So, this V can be written as V1 is nothing but what is the amount of current passing through here? And in the first resistor is I into. Let me write it separately to make you understand in a better way, children. So, V1, what is the value of V1? Amount of current into that resistor. This is first resistor, this is second resistor and this is third resistor. So what is the value? I into R1. Similarly V2, I into R2 and V3 is I into R3. Let us suppose that the equivalent resistor, the sum of the complete resistors R1, R2, R3 together is taken as one single resistor, something like this. The equivalent, some resultant value is there. If you add this and this and this, the total resistance, you may be getting some value. That equivalent resistor, let me name it as some R equivalent. And the combined potential be some V. Then we have, as the same amount of current is passing through the complete resistor, we can say that V is equals to I into R equivalent, where V is nothing but this value, the equivalent value. So V equivalent is equals to I into R equivalent. So substituting this value here, what we are getting means I R equivalent is equals to V1 is taken as IR1 plus IR2 plus IR3. Okay. So what is common, children? I times of R equivalent is equals to, when I is taken common, we have R1 plus R2 plus R3. So simplifying further, we have this I and I gets cancelled. Then we observe that the equivalent resistance is equals to sum of the individual resistance when connected in series. So what is the value, children? Whenever resistors are connected in series, we observe that R equivalent is equals to R1 plus R2 plus R3. Okay. So in the circuit, if you would like to know regarding this, how the resistors are connected in circuits means R1, R2, R3, circuit, some cell is connected, potential difference, positive terminal, negative terminal, some potential difference is applied. This is R1, R2, R3 and I current is passing in all the circuits. And the same current is supposed to be coming out. So this is how the resistors are shown in the circuit diagram. Okay? Well. So, now let us try to understand something regarding the parallel combination. Before that, if three combinations I have considered means it will be R1 plus R2 plus R3. Only 2 means R1 plus R2. If n number of such resistors are connected means R equivalent can be written as R1 plus R2 plus R3 plus so on, so on, so on, so forth, Rn. As many number of resistance, those many summations you have to calculate in the series combination. So shall we move to the next one, that is parallel combination as shown. In the parallel combination, what remains constant, children? Potential difference across the ends remains constant. Whereas the current will be different. So in one resistor, depending upon the resistance it offers R1, R2, R3, the current will be divided accordingly. Okay. So in this, as the potential difference remains constant and the current will be changing in the parallel combination, we can write that I can be written as I1 plus I2 plus I3 because this current divided into one is I1, the other I2 and here it is I3. So the total current that is passing through all the resistors is equals to sum of the individual currents. I is equals to I1 plus I2 plus I3. But children, from Ohm's law we know that V is equals to IR, or I can be written as V by R. I can be written as V by R. Okay. So based on that, we have, let us come across this. Since formula for I is equals to V by R, we can write I1 can be written as V by R1 because potential is same. Potential across all the ends here is same. What makes the difference? Only resistors is changing. So I1 is equals to V by R1. I2 can be taken as V by R2 and I3 is taken as V by R3. So now substituting here we have I is equals to V by R1 plus V by R2 plus V by R3. Instead of all the equivalent resistors, okay, if we consider all the three is combined to join one and that will give you the equivalent resistor, then the combined value can be written as R equivalent. Combined value of the resistors can be given as R equivalent. In that case, the value of I can be written as I is equals to V by R equivalent. I equivalent instead of that. This is indicating nothing but I equivalent. So I equivalent is equals to V by R equivalent and V potential difference is same and the resultant resistance is given as R equivalent. So replacing the same we have I equivalent is V by R equivalent is equals to V by R1 plus V by R2 plus V by R3. So all the cases we have V as common. Taking that V as common, we have 1 by R1 plus 1 by R2 plus 1 by R3. So simplifying further, we have 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So, whenever the circuit, the resistors are connected in series in the circuit, R equivalent is given by simply summation of all those values, that is R1 plus R2 plus R3. But when these resistors are connected in parallel, then the equivalent resistance is given by 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Summation of their reciprocals. Okay, children, and let us see how this is being connected in the circuits. These three resistors are joined in the circuit as something like this. Well, so this is positive terminal, this is negative terminal. Same amount of potential difference is applied across all the three resistors R1, R2, R3. Some potential difference, but here the current may be divided into I1, I2 and I3 respectively. So the same picture can also be drawn instead of like this. This can also be drawn something like this also. Makes no difference, children. Both diagrams are said. Okay, same potential difference and amount of current is divided. Only thing is the shape of the wire is changing. Okay. If you would like to replace the same, the combined with R equivalent, then it will be something like this. R equivalent. This is the potential difference. The combined value here is R equivalent and similarly, the combined value here, it's something like this. R1 plus R2 plus R3, the total value R equivalent is given. Okay. So this is your potential difference. Okay, well, so now moving to the parallel combination. Suppose the three resistors are connected in parallel, the formula would be something like this. Instead of this, only two resistors are connected, means 1 by R equivalent is equals to 1 by R1 plus 1 by R2. 1 by R equivalent is equals to 1 by R1 plus 1 by R2. After simplification, it can be written as 1 by R equivalent is cross multiply R2 plus R1 by R1, R2. But R equivalent can be written as R1, R2 upon R1 plus R. This is the case children for two resistors. Suppose n number of resistors are there, means then 1 by R equivalent can be written as 1 by R1 plus 1 by R2 plus 1 by R3 plus so on 1 by Rn for n number of resistors, for two number of resistors. That's it. Suppose if R1 is equals to R2, let us see what happens. The same case, if R1 is equals to R2. Then we observe that R equivalent is equals to, instead of R1, I can replace it with some R. Let us say both values and some value, say R. So R1 is also R, R2 is also R. So R into R upon R plus R, and R equivalent can be written as R into R by 2R. 1 R gets cancelled. Then R equivalent will be half of the previous value. R by 2 will be R by 2. Is that clear, my children? So, well, now, till far we have understood that these resistors can either be connected in series or in parallel. Not only this, these resistors can also be connected by both the cases. That means some in parallel and some in series. Together we can connect it. So next one, let us look into that. Okay. The combined form of series and parallel combination in the single circuit. So let us discuss the same.